Analyzing electrical hazards is essential if safe work procedures and policies are to be developed. If the protection method is inadequate, employees may be injured, or worse yet, killed. If the protection method is overly stringent, employees may circumvent the protective measures, resulting in injury or death. Accurate electrical hazard assessment, along with operating conditions that expose employees to these hazards, will go a long way to preventing workplace injuries and fatalities. An arc typically occurs when a short circuit has been introduced into an electrical power system. The intensity of the arc is directly proportional to the maximum current that the power system can deliver to that point. In other words, the available short circuit at a given location is one of the determining factors affecting the magnitude of the arc hazard. The simplest form of short circuit analysis is point-to-point analysis. Point-to-point analysis is used to calculate fault current at various locations within a radial electrical system. To understand short circuit current, consider the analogy between an electrical system and a reservoir. In this example, the reservoir is the utility system from which all electrical power is drawn. Under normal conditions, electrical energy is drawn in a controlled fashion until it reaches its utilization level. When a short circuit occurs in the power system, it is the equivalent to the dam breaking at the reservoir. Downstream devices may reduce the flow, but ultimately nothing will stop the torrent that rushes towards the end-use devices. This unconstrained flow, if not interrupted, will damage or destroy downstream equipment. It also contributes to the electrical arc hazard. A radial system consists of one direct path between the electrical source and the load or equipment. Note that in this example, a large distribution transformer is connected to a main switchboard 25 feet away. Downstream from the switchboard is a standard industrial motor. The local utility provides the short circuit current, while the transformer, cables, and switchboard fuses limit the amount of short circuit reaching the motor. Companies with established electrical safety programs tend to create greater awareness and self-discipline for their employees who perform work on or near exposed electrical conductors and circuit parts. In this, our 10th and final segment of our series on electrical safety for industrial facilities, we will turn our focus on electrical safety-related work practices as it applies to employee training and qualification, approach distances to live parts, personal and other protective equipment, and specific safety-related equipment and work practices. Employers are required to provide training to all employees who face a risk of electrical hazards that have not been reduced to a safe level. In other words, they must be trained to understand the specific hazards associated with electrical energy and possible injury. The type of training they receive can be either classroom, using programs such as this, or on the job. Personal protective clothing and equipment must be provided and used when work is performed in areas where there are electrical hazards. The equipment must be maintained in a safe and reliable condition and visually inspected before each use. When flame-resistant clothing is worn, it must cover all ignitable clothing and allow for movement and visibility. Proper head and eye protection must be worn to prevent injury from electric arcs, flashes, or from flying debris resulting from an electrical explosion. Hand and arm protection must be worn when there is a risk of injury from electric shock and burns due to contact with live parts. To protect from step and touch potential, insulated footwear must be worn when hazards from these types of sources exist. Many companies have a list of common work tasks respective to its hazard and risk category that describe the types of personal protective equipment required for the job. If you have any questions regarding what type of personal protective equipment is required, talk to your supervisor. Another important aspect associated with electrical safety-related work practices deals with the use of specific safety-related equipment. Test instruments and equipment fall into this category. Only qualified personnel should perform testing work on or near live parts operating at 50 volts or more. test instruments and equipment, and all associated test leads, cables, power cords, probes, and connectors must be visually inspected for external defects and damage before the equipment is used. If damage or defect is detected, the device must be taken out of service. Load-rated switches and circuit breakers or other devices specifically designed as disconnecting means should be used for opening, reversing, or closing of circuits under load conditions.